Okay, this is your video for 3.6. This one's really heavily algebra based as well, and a bunch of this we already did in our algebra review, so I'm going to treat this like a review. If it's not, you need to come in and get some tutoring because I'm not going to in-depth teach this. This is just a review. Okay, so the three forms for a linear equation. Slope-intercept form is best used when given a slope and the y-intercept. Or if you have a graph, it's the easiest to graph, and that's y equals mx plus b. Point slope is best used when given a point and a slope, hence point slope formula. Or if you're given a table, you can get the slope and then have a bunch of points to choose from. So that's slope and point slope. Remember, this y and this x will stay in the equation, and you will plug in the coordinate point into x1, y1, and you'll plug in the slope, but the y and the x will stay. Standard form is best used when you want to find the x and the y-intercepts, and we don't use this one too much now, but you'll use it a lot in Algebra 2. Go ahead and fill this in on your vocabulary chart, okay? Alright, so point slope form, we already talked about that one. Just one thing I want to mention is notice that the minus signs, y minus y1 and x minus x1, they belong to the formula. So even though this is a positive 3, when you plug it into the formula, it's y minus 3 because the minus sign belongs to the formula. So if you happen to have one that was like negative 2, 4, you would say y minus 4 is equal to I just noticed they did this wrong. If this is the x coordinate and this is the y coordinate, this should be y minus 4 equals 2 times x minus 3. That's the x coordinate. Okay, so if you were doing this one, you would say y minus 4 is equal to we'll use the same slope, 2 times x minus a negative 2. So minus from the formula, negative from the coordinate. So if you had two minuses together, you would change that to a positive. So if you don't remember that from Algebra 1, there's a little heads up. Slope-intercept form is the one we use the most. This is the slope. This is the y-intercept. You just plug them straight in. We talked about vertical and horizontal on the last video. Vertical, remember, is up and down, and it has an undefined slope. It crosses the x-axis, so it's x equals and then wherever it crosses. Which axis does it cross and where does it cross? Horizontal, remember, is the side to side, and it has a slope of 0. Which axis does it cross and where does it cross? Okay, so let's try these first two. Write the equation of each line in the given form. So I want to have a slope of 3 through the point 2, 1 in point slope form. So I'm going to go ahead and jot down point slope form so you can see me plug into it. So y minus, the y coordinate is 1. The slope is 3 times x minus the x coordinate is 2. Now it asked us to leave it in point slope form, so I don't have to solve or anything. This is my final answer right here. Now, if it did ask you to put it in a slope-intercept, you would distribute the 3 and then move the 1 over, just using your regular algebra skills. Okay, through 0, 4 and negative 1, 2 and slope-intercept. So the first thing we need is the slope. So we're going to do what we did last time. We're going to do change in y over change in x to find the slope. So from 4 to 2, we went down 2. From 0 to 1, we went, 0 to negative 1, we went down 1. So that is a slope of 2. Now, most instances, you would take this slope and you would pick either point you would want to, plug it into point slope like we did here, and then solve it out like I was just talking about. You can kind of cheat with this one because you notice that this 0, 4, that is your y-intercept already. So you could go ahead and use slope, intercept, and plug it on in if you wanted to do that. I'm going to go ahead and show you the full way out just in case they don't give you the intercept on any of the other ones. So you would pick your point and your slope, and you would say y minus 4 is equal to 2 times x minus 0. You would distribute the 2, so y minus 4 equals 2x minus 0. and then you would move the 4 over to the other side. Y equals 2x plus 4. And that's the procedure that you would use if they didn't already give you the intercept. Okay, let's move on and try C. Okay, so this one they gave us the x-intercept and the y-intercept, and they want it in point-slope form. Let's go ahead and write these as a coordinate. The x-intercept is at 2, 0, and the y-intercept is at 0, 3. That helps us out a little bit. Okay, we need the slope, so let's do our change in y over change in x. So from 0 to 3, I went up 3. From 2 to 0, I went down 2. So your slope is -3/2. And then for this one, you can choose either point you want to, because it doesn't matter in point slope, you can choose whichever one. So let's choose this one. It'll be easier for us. Okay, so here we go. Y minus the y coordinate is 3 equals the slope, -3/2. X minus the x coordinate. And you could choose to leave this off if you wanted to, or you can put it in there. It's not wrong either way. Now, they told us we could leave this in point slope form, so we're done. Right here, this is our final answer. Just leave it put. Okay, I'm going to let you try C and D. On E, there is a coordinate that's 1, +2. I want you to change that to 1, -2. Before you do E, change that coordinate. Okay, so let's look at D. This one has a slope of 0, which means it's a horizontal line, and we've been talking about horizontal lines are y equals a number. So all you have to do is put y equals. Look at your coordinate. Which one of these is y? The 6. So y equals 6, and that's all there is. There's no calculations or anything. Had it been an undefined slope, you would say that's x equals, and you would pick x equals 4. E, maybe. Okay, let's find the slope first. From 2 to -2 is -4, and from -3 to 1 is +4. So you have a slope of -1, and you can choose either point you want to. So I wrote them with both points so you can check your answer. If you choose this point, you have y minus 2 equals -1 times x plus 3. If you choose the second point, you have y plus 2 equals -1 times x minus 1. Either of those is correct. Okay, so let's do some graphing. So this first one is in slope-intercept, so that should be pretty easy. All you have to do is graph your intercept first at 3, and then follow along with the slope. This slope says up 3 over 2, so 1, 2, 3, 1, 2. All you have to have is 2 points, but we can put a couple extras just to make sure we're going to have a nice straight line, but you only are required to make 2 points. This one's a little different because it's in slope-intercept. So the first thing you need to do is find the point. And remember with points, it's in point-slope form. So remember with the point, it's the opposite sign of what it looks like, because this is really y minus a -3 equals -2 times x minus 1. And remember, the minus sign belongs to the formula, so all you want is the real number. So the x-coordinate is 1. The y-coordinate is -3, and then the slope is -2. Once you identify those, then you can graph it pretty easily. That's the hard part. So I'm going to go over 1 and down 3 to put my point. From there, I just follow the slope. Down 2 over 1, down 2 over 1. So identifying what the coordinate point is the tricky part. After that, it's pretty easy. So you have to remember it's the opposite sign of what you think. If it says +3, it's -3. If it says -1, it's +1. Y'all switch over and try C and D on the next page, and we'll see if you get those right. Okay, so this one's x equals -2, so this is one of the weird ones. So you say, which axis does it cross, and where does it cross? This crosses the x-axis at -2, so you put your dot at -2, and then that is a vertical line, so you just draw the vertical line crossing the x-axis at -2. This one, you pick out your point. Your point is -2, 4, and your slope is 1/2. -2, 4, up 1 over 2, up 1 over 2. Okay, Last example is systems of equations. So we had a couple of these earlier in the chapter. Now we're going to classify them. So if you have a system, remember systems just mean two equations working together. You have three possible scenarios of what could happen. Your lines could be parallel. You know you have parallel lines if they have the same slope but a different y-intercept. You want them to have a different y-intercept because you want them to start at a different point on the graph. But then they have the same slope, so they're going to go up 5 over 1, up 5 over 1. So they're both going to be going up by the same amount each time, so they won't cross. Intersecting is the easy one. As long as they have different slopes, that's the only criteria if their slopes are different. And they could even be like y equals negative 4x and y equals 4x. So as long as they're different, even if one's negative and one's positive, that's all you need. We don't even care what the y-intercepts are. They could be different or they could be the same. It doesn't even matter. Coinciding might be a new term to you. That means the exact same line. So they have the same slope and the same y-intercept. So if you were to graph those, it would look like you only graphed one line, but it would be two lines right on top of each other, coinciding. So same everything. That's why you have to be careful with parallel that they have different y-intercepts, because that's the only difference between parallel and coinciding. Okay, let's look at these and classify. So these two are already in slope-intercept, so it should be very easy to check. These have the same slope, but they have different y-intercepts, so that falls into the parallel category. There's no work to be done here, so all you need to do is check your chart. So make sure you know this chart because it's all kind of vocabulary. There's no really work to be done. Okay, let's try B. So this one is in slope-intercept, ready to go, but this one's not. So it's in standard form, so I'm going to have to solve it. So let's move the 6x over. Negative 2y equals negative 6x. Divide by negative 2, y equals 3x. And you could put the plus 0 if you want to. You don't really need it. So then let's classify. They have the same slope, but different y-intercepts. That's what we just saw on the other one. So that is also parallel. Okay, y'all pause and try the third one, and let's see if you get that one right. Okay, neither of these is in slope-intercept, so we're going to have to solve them. So we move the 3x over, and then we divide by 2 to get y equals negative 3 halves x plus 7 halves. This one you don't have to move the x. All you have to do is divide by 3 all the way across. Y equals 4 thirds x plus 7 thirds. So these have different slopes, and that's all I need to know. As soon as I see they have different slopes, those are intersecting, and that's all there is. Okay, see you tomorrow.